All right. So now we're going to mess around with the ideas of complex numbers and how they can be used in quadratic equations. So the main idea for why complex numbers are useful is because you know how when we did parabolas, we would solve the solution by figuring out wherever the parabola equaled 0. That would let us know what the x-intercepts were. But what if it never touches the x-intercept? Or the x-axis, I should say. So if it never touches the x-axis, what happens is this would still have an answer. The only problem is it would be imaginary numbers. So by knowing this idea that imaginary numbers exist, whenever we use this formula, the quadratic formula, over 2a, if we get a negative number inside here, if we get an imaginary number, in other words, then that tells us that our parabola is not touching the x-axis. Because if this is imaginary, it doesn't matter if we add or subtract it, it's never touching the x-axis. If this is called the discriminant, by the way. Discriminant. Oh, and one thing, guys, I haven't said this recently, but what I recommend, I'm just kind of starting to tell all my classes this because I know new people are coming in. Um, take notes. So, for example, you can take notes on that fact that this is a quadratic formula and then go back and do the tutorials. I know it does take a little longer, but that way you're not like, let me switch the tab, let me switch the other tab, let me go back and forth, and it doesn't become too complicated. Wondering if you were still making the third video for that one assignment. What assignment are you talking about, Victoria? Oh, I know which one you're talking about. Thank you for leaving the comment. I probably haven't seen it yet because I was at the center yesterday. But yes, I'll add that to my list of things to do right now. I have a to-do list. So video. So the third video assignment. 3 assignments. I completely forgot about that. Thank you for reminding me. I will make that video though. All right, cool. So yeah, I will get down to that. Well, that hurt my ears, Nelson. I just wanted to not hear my fan, so I put on headphones, and then Nelson punished me. All right, guys. So here we're gonna describe how many solutions there are. So obviously, if it crosses the x-axis twice, there's 2 solutions. That is a very good question. I am. Thank you for reminding me. Even more important, Brianna, remind me to hit the save button. Because I have a few Algebra 1 students who are not happy with me for not hitting the save button. But thank you. And this one right here, this one has one solution because it only touches the x-axis one time. This one doesn't touch it at all, so we would say no real solutions. And this is where we start changing our answers because before we used to say no solutions. Now that we know that imaginary numbers exist, we say no real solutions. And then 2 solutions. So those are our options. It's either going to be 1 solution, 2 solutions, or no real solutions. And that's all. I imagine we're going to cover it in this module. This idea of the discriminant, that b squared minus 4ac. ¿Dónde está mi pluma? There it is. B squared minus 4ac. So yeah, we're going to be looking at how this affects these problems. So as always, check out the intro videos. I've seen several people have questions on things, and then like I started looking at the intro videos and I'm like, wait a minute, all of that's right here. And this is actually, I just saw right now, this is a good review on negative and positive numbers. So if you guys still have trouble with those, it's always good to see this and squares. Again, I cannot emphasize enough how important like watching these videos are. I just don't want to spend a lot of time. I don't want to go, let's watch a video inside a video, because then everyone's on YouTube like, what's the point of me watching this video if I could have just watched that? Plus, everyone's on YouTube is always confused at me telling Nelson to not have to yell into my ears. Yeah, yeah, not from OFL. I had to like delete some because some people are mean and they just want answers and they don't ask for them nicely. All right, so complex numbers, we've already kind of gone over this. Real numbers are the A, the imaginary parts, just this BI. So if our answer is complex, then we're going to get those two solutions, but apparently they're still not talking about that. Why are we talking about this? Oh, it's just getting us ready for the idea of factoring. So let's talk about factoring. So the interesting part about imaginary numbers is this idea of us being able to multiply and get a complex number, but it's also possible for us to multiply and get rid of certain numbers. See how that I squared is making it a -1? We're going to learn about how we can multiply two complex numbers and get a real answer. So let's get into this. So factoring, always factor by group. There's different ways, basically. I don't know why this is going into factoring when we already did a lesson on factoring, but I guess this is a good review. So if you're factoring quadratics, you always want to get your GCF out first. Then you can do factor by grouping. I've taught you guys to do the box method. If you guys like this idea of factor by grouping, I mean, you can try it. They do it by what's called the AC method, meaning that we multiply, oh my gosh, we multiply this A times this C, and we get this -18. And then we just find factors of it that add up to this middle number. So factors of 18. So -9 times, or sorry, -2 times 9 gives us -18, but they add up to 7. So that's this factoring by grouping method, is we do the -2x and the 9x. And that's how we can factor by grouping. I honestly think the box method is easier than doing what's called this AC method. But let me know if you guys want me to cover this AC method. I can teach it. I've taught it a few times. I just always like the box method. And then there's factoring by squaring. You just take the square root, and that's pretty much it. So let's get into the actual thing. So we're going to practice factoring quadratics. I'll kind of go over how to factor it using the box method or using the AC method. If they give me one that I can do the AC method. Okay, so they're not giving one where I can do the AC method. So let's take a look at this one. If you guys saw that one weird video back when I was trying to rush you guys through it, this would be known as difference of, or I'm sorry, sum of squares, because you can square root 9, you can square root the 16. This, what happens here is that the middle term cancels out. So if you did it by box method, I know I said I would try to do the other method, but they're not giving me anything I can do here. We would see that we get this 9, and one of them is um, plus 3, the other one's 3. So there's no real way for us to factor this, because what ends up happening here is we end up getting this 12x and another 12x here, which we should have a 24x. So we cannot factor this. I just kind of wanted to go over this one. We can't factor it with real numbers at least. So let's take a look at this one. When it's a difference of squares, these ones are very factorable. It's this, if we did a box method, it's this idea that this is a 3x, this is a 3x. We want this -1, so we can do a +1 and a -1. And what happens here is these x's cancel out. So that's how come there's no x here. So that's what's known as difference of squares. I feel like now they're making it easier on you guys. So if you guys had trouble with that one unit, apparently Admentum just hates you guys and wants you to do the hard method first and then go like, hey, now we're going to make it simple for you. All right, and this one's also a difference of squares because we can square root both of them. The square root of x is x, the square root of 6, or 36 is 6. So that's where we can do this difference of squares. Another one we can do here is we can look at this one right here. We can factor out that 4. So if we factor out 4, if we take out the GCF, because we can divide both of these by 4, we end up getting this x squared minus 4. And here, this is the idea of dose, difference of squares. This whole thing that we've been doing, where we have this plus or minus that cancels out that middle number. And we can submit that, and we get that going. All right, so which two binomials in part A haven't had so the two binomials that we have are these sum of squares, and we're going to see how we can cancel these out. So I had the feeling that's where this was going. So this idea of control up squared plus 16, and the other one was 16x control up plus 9 plus 9. So those are two that we could not square. And that's this idea that it's a square root, but it's a sum. All of these have been difference of squares, DOS, DOS. If we look at these ones are sum of squares, SOS. We need help. And what's going to help us out, what made these different from the other ones? And we would say these are sum of squares, not difference. Difference meaning subtraction, difference of squares. If we notice with the difference of squares, we're just changing that plus or minus. These are known as conjugates of each other. Conjugates. The idea of they're the same thing, just the middle number has a different sign. So what's the product of these two? So check this out. So this one, if we look at it, I'm going to do a box method to multiply these. I have this x 3i, and then this x negative 3i. Well, here I get this x squared. Over here I get 3xi, and over here I get negative 3xi. So right off the back, I can see that these two are going to cancel out. And then I get this 3, oh, I'm sorry, 3, 9. 3 times 3 is 9, duh. and then I get I squared. Well, I squared is -1. So that means that we get this x squared minus 9 because -1 times 9. Oh, I'm sorry. This was supposed to be -9 because it's -3 times 3. I'm sorry, guys. I'm tired. So we get that 9, that x squared plus 9, which is similar to this over here. So let's kind of just write this out. They're going to get to that one. So we're going to get this x squared plus 9. All right, cool. And now we're going to do it with 4. Well, we can kind of guess what's happening here. Now that we have conjugates here, we're going to see that the i's kind of disappear. So that's one of the interesting things about imaginary numbers. They used to call these imaginary numbers, and the name kind of just stuck. These are still very useful because if we multiply these out, we're going to end up getting this -16i squared, which guess what? That's just +16. And we see this. I'm just using the box method to kind of illustrate how these two cancel out. So when we do this, we're getting the exact same thing, except it's going to be for the 16. So I'm just going to copy and paste that and then just go to my equation editor. Apparently my equation editor hates me. Oh, that's what happened. You're supposed to copy it where it shows this little box. Momentum just hates me. All right. Oh, you know what, Nelson? If you do another meme, I'll make it a thumbnail for my videos. I don't know. Make it math related but funny. I'll change. I'll change one of my thumbnail. That thumbnail where I'm like yelling at Adventum. Uh, I think that's the one that Victoria was talking about. That I still need to make that third video for. I'll make the second video that thumbnail. Oh, you know what? I'll make. Yes, yes, do it, Nelson. um, I'll make the third video since I haven't made a thumbnail for the third video that I still need to do. That meme of me yelling at Adventum's going to be the thumbnail for that third video that Victoria wants. So I don't know. Get creative, man. You're the meme guy. I'm just the guy telling you to make memes. Well, I'm also the guy Oh, go ahead. I'm also the guy telling you to do your math homework, but I have a feeling telling you to do memes is more productive or more possible. So what's going to happen here is these two cancel out, and we're going to be left here with this x squared plus. I'm too lazy to go into the equation editor, guys. Plus 64. I use this little caret to symbolize that it's a squared, but honestly, I really should just put this into the equation editor. There. It understands. I mean, a lot of it, I think they do want you to use the equation editor, but usually, like the teachers are grading this, so as long as the teacher understands what you're doing, you should really use the equation editor. Though, there, I fixed it. um, Desmos understands it. I know Desmos is a little smarter than Edmentum. So, for example, if you guys ever use any software that needs this, you can always do this. Like you don't see it, but I typed in shift 6, and it already made it an exponent. Instead of having for me having to look for this button or this button, I can just use shift. Was it 6? Yeah, shift 6, and it does use it. All right, so now we're going to describe the patterns that we see here. So we're going to see that when we do the conjugate, the of complex numbers. Remember, complex numbers are that a plus bi. So if we do the conjugate of complex numbers, the reason why I keep using the word conjugate over and over and over again is because it's easier for me to say that instead of going like, whenever we do two things and instead of putting a plus sign, we put a negative sign, the middle thing disappears. It's easier for me to just say conjugate. So whenever we do the conjugate of a complex number, the answer is a real number. Like we get rid of all the complex stuff. Generalize the patterns for this. Generalize the patterns notice in part D to create a rule. For example, if we see this, what rule can we? Okay, so I'm going to do this. I'm going to say the rule is going to be A plus BI times A minus BI. And the rule we should have seen here was this equals A. Oh, I'm going to have to use the equation editor. This equals A squared. Oh, I think I know what Nelson was talking about now. No, Nelson. For some reason, it meant I'm stupid. And if you use shift 6, it just does this caret. They're like the only program I've ever seen that uses control up instead of shift 6. So you have to use control up if you want to do it. I don't know why they don't use shift 6. Like, they're literally the only program I've seen that doesn't use that. Great. Now I'm going to keep doing shift 6. So that's our rule here. Is if we're doing the conjugate, what ends up happening is we get this sum of squares. Was someone going to say something? Okay. So now we have a sum of squares here. Okay, so according to this rule that I just made up, I didn't really make this up. This is like a known rule in the math world. I have to take the square root of this. This is my a squared from right here, and this is my b squared. So according to this, I have to make the rule like this. The square root of x is, or the square root of x squared is x. The square root of 100 is 10, but I'm going to put an I because this is a sum of squares. And I have to multiply that by the conjugate. So what's going to happen here is if I made a box method, the i's would cancel out. Negative 10 times positive 10 is negative 100, but then we get this I squared. So just to kind of show it, 10I times positive 10, we get this negative 100I squared, which just turns into positive 100. And we would get this like 10xi minus 10xi in the diagonals of a box method, which would just cancel out the diagonals. So then this one over here would basically be the same thing. And what I like about this type of factoring is I don't have any exponents, so I don't have to use the equation editor. But now the square root of 36 is just 6, and the square root of 36 is 6. So we get this conjugate right here, this plus and minus. And now this is still the same thing. You can square root 16, you can square root 9. It's just now it's going to be 4x instead of just x. And the square root of 9 is 3. So we're going to change these 10s to 3. And if I multiplied this out, oops, I forgot to put a 4 here, we would get that answer. Is this making sense to everyone how we do a sum of squares? The only tricky part about this is just remembering that we have to take the square root of it. A lot of people think, oh, it's x squared plus 10. It's like, nope, you have to take the square root of it. Everybody understand? Anybody confused? Anybody awake? Okay. Are you just scour? Are you just scouring the videos for content, Nelson? All right. So evaluate how you did. So if you guys had trouble understanding this idea of dose, this idea of sum of difference of squares, with that a squared plus b squared is equal to, or I'm sorry, difference of squares. Blah. I don't think I'm awake, guys. If you had trouble with dose, like mentioned that you didn't really understand dose before, because Admentum like crammed. Admentum crammed a lot in that one unit. So if you guys are having trouble with, I think it's unit 2, I don't blame you. That one was something else. So just write down if you're having trouble with that, let me know. All right. And let's get into what we were supposed to learn from this. Oh, look, I made the rule right. So this is the rule for sum of squares. SOS, sum of squares. We have to have imaginary numbers in order to do sum of squares. All right. So these two canceled out. So that's all this is saying. In sum of squares, these two middle numbers right here are going to cancel out. That's the beauty of the imaginary numbers is when we do, I guess if we're doing FOIL, the OI cancels out this outer. So the idea of outer. So this is the outer and the inner, this little rainbow here. I used to do a lot of, before I did the box method a lot, I used to kind of say, like, oh, we just need to do the rainbow method to figure this out. And the reason why I said the rainbow method is usually 4 times 4 is 16. And then you usually know how to get this, well, if it was a square method, for example, you usually know how to get this 9. You just had to verify that the OI, the rainbow, was correct. And the rainbow, when it comes to the box method, that's just these two right here. All right. So let's kind of get into this. So they're just showing us all the logic behind it. So, for example, if we can't find the square root of a number, like this one, it's like, wait, we can't find the square root of 5. Let's just say it's the square root of 5. And we're adding it. So this is still a SOS. It's still a sum of squares. The only difference is it's not a perfect square. It's special. So we're just going to take a square root symbol. So we can still do this. This rule still applies because we're adding it. We're just doing a square root just to make it easier. All right, so let's see how we can do this with something that's not a sum of squares. So what they're doing here is they're basically saying, hey, why don't we do this 3 plus I? Now, they'll show us why this works right now. I actually don't know why they're doing this 3 plus I. They're kind of doing this, I don't know why they're doing this backwards. Yeah, this one's weird. All right, now let's look at how to factor a quadratic, we'll work backward by looking at the product of these two equal factors. So yeah, to multiply this, we use a FOIL method. So apparently they're just trying to, they're like, hey, this is the answer. And they're not explaining why it's the answer. So if we do FOIL this, so what we're going to end up doing when we FOIL is we're going to do this idea of first is this one. Then we're going to do outer, which is this, which is how we got this method right here. Then we're going to do inner, which is this combined with that, which is how we're going to get this part right here. And then we're going to do the last, which is this one and this, which is why this turns to positive because we have two negatives there. So let me kind of make this a little better. Boop, boop. And then we're going to do this one right here. So the reason why I like circle it is to let you guys know that we're taking the negative as well. And the last one, we're taking all of this times all of this. So that's why it turns into a positive. What's happening here is that because it's a conjugate, these two are going to cancel out. And these two cancel out. So what we're left with at the end, this I squared at the very end, because they're going to do another FOIL here that they don't mention. I don't know why it doesn't mention, but that's just how Amentum does stuff. Is they distribute, and then they're going to FOIL this. It goes away. So I don't know why they're scaring you like this, guys. I'm sorry that they are, but they're just kind of proving to you like, hey, you can factor anything as long as you have these imaginary numbers. Yes, Nelson, special like you. I know you said that a while ago, but I just saw it in the chat. So now what they're saying is like, we already knew how to do sum of squares, but how can we apply this to this? Why is this possible? So what they're going to do here is first, they want to factor out what are they doing here? So they're still on this. I don't know why. I feel like Inventum always teaches you guys backwards. They're saying like, hey, we're going to just take this out here. And what they're doing here is x minus a negative is they're going to factor out to make these the same. So I don't know why. Why are they doing this? They're making this way more complicated than it has to be. Edmentum, why can't you be normal? So, why are they doing all this? Now let's plug in these values. So again, they keep doing this idea of like we're working it backwards, but I feel that's going to confuse you guys more. Watch the video on the screen to process this. I'm gonna recommend that you guys watch this. I'm gonna skim through it right now to see if it does help out. I don't know where they're getting that 3i. To me, it's just kind of weird. So we have this. Oh, that's what they're doing. Why didn't you guys say? They really should have mentioned this. Okay, now I'm behind them. What they're doing is they're essentially completing the square. So what they're doing here is they're taking this -6 and squaring it. I don't know if you guys remember the idea of completing the square, but the idea behind completing the square is that what we do is we're going to take this number divided by 2 and square it. So that's where they're getting that 3. And they're going to get that plus I in order to get that conjugate. So what happens here is when we do all of this, we're going to end up getting that 10. So I get what they're doing. So what they're doing here, now I can go back and explain this. I don't know why they didn't tell you this before. If we cut this 6 in half, we get a 3. But also, if we do the plus I, the negative would cancel out here. So they're just doing this plus and squaring it. So because it's a negative, that's why they're doing that. Okay, that makes a little more sense. So definitely watch that video, guys. I don't have enough time to go through it here. Oh no, I didn't want you guys to see the answer, but since you guys do. So what we're doing here is this idea of we're going to take this, we're going to take half of it and square it. So we end up getting this 16 here, right? But we can't create this positive 16 out of nowhere. If you guys need help with reviewing completing the square, the main idea is that you just take half of your b term and you square it. And then you're going to add it to the term. Now, the thing is, you can't just create a number out of nowhere. So, in order to balance out this positive 6 that you made up out of nowhere, you're going to have to subtract 6. Well, from here, what we're going to do is this ends up being a 1. Well, what's another way of saying this 1? Oh, well, we can just say that this is negative 1. And if we take the square root of that, we're going to get this I. So that's what's happening here is they're basically taking half of this, squaring it, and they want to make this I somehow. So for example, if for some reason this was, let's say this was 20, when we subtracted it, it would be plus 4 out here. So because it's plus 4, plus 4 out here, it would be negative 4. So it would turn into this like 2I situation instead of just an I situation. So they're making it easy on us by making it 1. This is the one thing I do acknowledge that Edmentum does right is they know how to pick their numbers to make it easy. They just don't know what order to teach in. But I'll go through a problem similar to this to show you guys instead of just running through this. So hopefully we'll get like a practice problem right now. Okay, so here, for example, if we're creating this, an easy way of factoring this is just taking the GCF. So if we take the GCF, we factor out at x, we get this x squared plus this. Guess what? This right here is an SOS, sum of squares, which we can break down using our formula that a plus bi times a minus bi. Because this is a squared plus b squared. That's where I'm getting these numbers from, the a squared plus b squared. Square root of x squared is x. Square root of b squared is 80, or square root of 81 is 9. Now, let's say we wanted to do it with something like this. Well, this we can do by grouping. This is a cubic with 4 terms. Well, if we want to do this, what we're going to do here is we're going to group these two together. We can factor out an x squared. We group these two together. We can factor out a 9. Now, if we notice here, what's happening is we get this x plus 8 and this x plus 8. Why don't we just factor this out? Which is what they did right here. They just factored it out. And then these things go in here. So that's how you factor by grouping. Usually you use it on cubes with 4 terms. It's the easiest way to factor by grouping. Again, you can do it with a quadratic, which we haven't had a chance to do, but the difference of squares. This one, again, this one you should have memorized, DOS, difference of squares. It's this idea of a squared minus b squared is equal to a plus b, a minus b. Now let's say we have a quadratic with 3 terms. Well, they're saying like, hey, why don't you just FOIL it, or why don't you find some way to do this? So they're saying like just box method it. If you box method this, x, because this is an x squared, this is a 50, and you can just do this. So again, I said I would use the AC method, but this one's really easy. Our A is 1, our C is 50. So what we're going to do here is we're going to put a 50 at the bottom, and our B term is 27. So what two numbers give us 27 when we add them, but give us 50 when we multiply? That's 2 and 25. If we add 2 and 25, this adds up to this. If we multiply them, we get 50. This is known as the X method. So I remember in high school, they used to call it the X box method because this was an X, or you can always use the box method. It always confused me why they called it one method because there's two different methods. There's the X method and there's the box method. And they always called it the X box method, which still doesn't make sense to me. But if you like doing the X method, you have to use the AC method, which is this idea of doing the A and the B. Now, the difference here is they call this U substitution because see how this is an x squared or x to the fourth? Instead of calling it x to the fourth, they're like, and doing it with the box method and making it all easy, they're like, just pretend it's U squared. And if this is U, if U equals x squared, then this right here is U. So it's a little confusing. If you use the box method, I think it's a lot easier to kind of understand it. So it's up to you, whichever way you want to do it. U substitution is interesting. I used to use it a lot, but after a while, you just kind of recognize the pattern. So use this if you really want to get rid of this x to the fourth. All right, let's try to get into an actual practice problem. Let's pretend those weren't there. So if I look at this, I can pretend that this is u squared minus 81, where in this case, my u equals x squared. So if I did this in a box method, or even if I didn't do the box method, let's say I did this using the u method. Well, I see that this is a dose. So when I do dose, I'm like, oh, cool, this is u minus 9, u plus 9. Okay, but then when I plug in my x again, I get this x squared minus 9 times x squared plus 9. Wait a minute, this is an SOS, and this is a dose. So by seeing that, now what I can do here is this becomes x plus 3, x minus 3, and then by doing the SOS, I know that this is x plus 3i, x minus 3i. So this is just kind of just using the dose and the SOS and the U substitution. There's a lot going on here. Now this one, oh, guess what? This is a cubic with 4 terms. They want us to do factor by grouping. So if I want to factor this by grouping, I would do x cubed minus 2x squared. That's a group. Plus 9x minus 18. This is a group. I look at this, I'm like, oh, cool, I can take out an x squared, and x minus 2. I look at these two, I'm like, cool, I can take out a 9, because 9 goes into 9 and 18, and I get x minus 2. Oh, cool. I have this and this that are the same. I'm just going to factor those out, leaving me with this x squared plus 9 here, which guess what? This is an SOS, sum of squares. So I'll give you guys some time to copy that down. I realize I'm going fast. Let me know if I'm ever going too fast for you guys to take notes. Um, but we get this SOS right here. So then if I'm looking at it as an SOS, I'm like, oh, this has to be x plus 3i, x minus 3i. And the reason for that is the square root of 9 is 3, but since it's a sum, I'm going to want to do this I and I here. Is everyone following along? Did this just get really complicated? Let me know if there's anything you guys want me to like cover, because I know it's a lot. Everyone good? All right. So from that, we remembered this x minus 2. What's up, Nelson? The whole thing? Okay. So that's what's happening here. I got the x minus 2 from when I did the grouping, and then I had that SOS, which made this. That's why I haven't erased this part yet. Now, here comes the tricky part. This is the part they really want you to kind of start getting into. Is I'm just going to kind of do this by doing that b squared method. So what I'm going to do is I'm going to take half of this and square it. So if I take half of that and square it, I'm going to get this x to the fourth plus 5x. I end up getting this. Ooh, that's nasty. 2.5 squared. What do they want us to do here? I'm going to box method this. The idea here is this x to the fourth and this negative 36. So this is 6 and negative 6. That's what I would guess they want us to do. Let's see if this works. So it's negative 6x squared, positive 6x squared. That's not going to work. So we want to get this 5. Let's kind of take a look here. How can I get 5? Well, what I can do is I can think of this as positive 9 and this negative 4. That also gives me 36, but more importantly, it gives me 5x squared here. So the factors here, now if I look at this, I have a dose here, and I have an SOS here. So in order to do the SOS, let me do the dose first, because the dose is easy. It's all real numbers. It's just x minus 2, x plus 2, and the SOS is going to be x plus 3, because of the square root of 9, and x minus 3. So hopefully that helped you guys out. Again, they're doing it by factoring, by grouping. I don't know why I like do all this stuff here, but I like doing, well, actually I do know why. I do it because they don't use the box method. The box method I think is the best way to do it. Because here it's like, well, how did they do this? They didn't do the box method. So it's kind of hard to see what they're doing here. You can also use the X method, because this would have been, what is this, 5, and this would have been negative 36, and you would have been like, oh, cool, that's negative 4 times 9. If you add these two together, you get 5. If you multiply them, you get that 36. So I didn't cover the X method. I saw someone, when they submitted their work, they did the X method, and I was like, I should have covered that in class. So I'm going to start covering it. All right. And then we'll get into solving quadratics with complex solutions in the next class. So we're going to start on slide 21. I'm going to hit pause before Brianna yells at me, because I know she's been waiting